So we discussed how to find the limit. We are going to plug in c. If that gives us a finite number, we're done. If it gives us 0 over 0, then that means that we need to factor, cancel out, and then plug in. Now, in the process of factoring, that can sometimes be a little bit of a bear to handle. So here is an example where when you plug in x is equal to -2, it does give you the 0 over 0 case. And so we need to factor both the numerator and the denominator. Now, let's just focus on factoring the 2x squared minus 4x minus 16. The first question in factoring is always, is there a GCF? So when you look at 2, 4, and 16, you have a GCF of 2. So we would want to start our factorization by taking out the 2, and then we would have x squared minus 2x minus 8. Now we need to factor or try to factor the resulting trinomial. So to do that, we would think about the factors of 1 times -8. So that, of course, gives us -8. And we need them to sum to give us -2. So we need two numbers that multiply together to give us -8 and that add together to give us -2. So trying different combinations, we would get 4 and 2. If we take 4 times 2, that could give us a -8 depending on the sign. And if we take -4 plus 2, that gives us the -2 that we need. And we just go over here and verify. If I take -4 times 2, I do get the -8 that I need. And if I add them together, I get the -2. So that tells us that -4, 2 is going to be our winning combination. Now, if you want a method that will always work forever, what you can do is you can take your x squared minus 2x minus 8 trinomial, and you can split this up into -4x and positive 2x for the middle term. And then the x squared and the -8 will still be there. Now that we have 4 terms, we would go through our grouping method. So we would look at the first 2 terms and say, okay, they have a common factor of x, so we are going to have x minus 4 left over. Again, we're dividing this by x, dividing this by x to get the x minus 4. Now, to get the resulting x minus 4 on the other side, we look at what we have. So we currently have a 2x, and we want to get just an x. So that would tell us, if we cross these out, that we need to factor out a GCF of positive 2. So then what we can do is we can say, okay, now that both sides before and after the red line, we have this x minus 4, that is a GCF. So we can bring out the x minus 4, and then we are left over with the x from the first group and the plus 2 from the second group. So this will give us x plus 2. Now, if you notice here, you have -4 and 2 as your winning combination, and technically we could have skipped this whole grouping part because of the fact that we have a 1x squared. So because you have a 1x squared, you can plop it down as x, and then just put the 2 numbers there. So what we are finding at the end of the day is that our numerator factors as 2 for the GCF, and then x minus 4 and x plus 2. Now, of course, we also have to look at the denominator. So when we look at the denominator, we see that that is 4 minus x squared. And you'll notice that this is just 2 terms. We have a perfect square in 4, a perfect square in x squared. So that means that we have a difference of 2 squares. And as we talked about on the previous video, when you have a difference of 2 squares, you want to take the square root of the first, which would just give us 2, and then the square root of the last, again ignoring the negative sign, which would give us x. So that tells us that our denominator would factor as 2 and x, 2 and x, and then we need to put a positive and a minus so that the middle terms will cross out. Right. So sometimes with these limits, the factoring can be the hardest part. There's a lot of work involved in that. But once we get our numerator and denominator factored, then we will return to the limit and plug in those factorizations. So again, our limit is now going to look like the factored form of the numerator, which is 2 times x minus 4, x plus 2. And then the factored form of the denominator, which is 2 plus x, 2 minus x. Now, remember that in all of this work, what we are trying to do is get to the point where our x arrow negative 2 becomes x minus negative 2, telling us that we really want to cross out an x plus 2. And if you look at our factorization, we have an x plus 2 in the numerator. And if I were to rewrite this factor, this of course would be x plus 2. So I can cross that out. Now, once I've crossed out or canceled out the common factor, then I say, okay, can I plug in and get a finite number? So what's left over here is 2 times x minus 4 over 2 minus x. So we plug in, and remember that when we plug in, we lose this limit notation. So we have just 2 times negative 2 minus 4 over 2 minus, and then our x is negative 2. So what we're looking at here is we're looking at 2 times negative 6, so negative 12, over, and then in the denominator, we really have 2 plus 2, or 4. So that tells us that our limit is equal to negative 3.